Hi everyone, my name is Geoffrey, and I'm really excited to be here today to give you a quick preview about our work on Skyline. So this is work done at the University of Toronto and the Vector Institute, and is joint work with Tovi Grossman and my advisor Gennady Pekhimenko at the University of Toronto. So to get started, I'm going to play a quick teaser video to show you what Skyline can do. We present Skyline, a new interactive tool for deep neural network training that supports in-editor computational performance profiling, visualization, and debugging. Skyline's visualizations are linked to specific lines of code. They update automatically in the background when the code is changed, and they can also be manipulated, leading to mutations to the batch size in the code that suggest how to achieve the manipulated performance. So why deep neural networks? Well, deep neural networks have led to many breakthroughs in many classical machine learning tasks, including image classification, machine translation, object detection, and speech recognition. And as a result, they're widely used throughout industry and academia. But one of the big problems of using deep neural networks in practice is that they are incredibly computationally expensive to train. So on this graph on the left, this is from OpenAI's AI and Compute blog post. They're plotting the amount of compute it takes to train many of the state-of-the-art neural networks that came out each year. So on the x-axis are the years, and the y-axis is the amount of compute in a logarithmic scale. So the main takeaway here is that the amount of compute needed to train these models has actually been increasing at an exponential rate with a 3.4-month doubling time. And one really interesting example of this is OpenAI's GPT-3 language model. The folks over at Lambda Labs did a quick analysis of this model, and they found that actually it would take around 355 years to train this model on a commodity graphics processing unit, and that this would equate to about 4.6 million in cloud compute costs. So the key takeaway here is that training performance and optimizing it is actually a really important problem, unless of course you have a lot of resources or time. And if you did a quick search online, you'll actually see that there are numerous situations of everyday users wondering why their models are training slowly, why they're running slowly, and what they can perhaps potentially do about it to actually rectify the problem. So part of the issue is that deep learning users really work at this high level of abstraction. They implement their models in Python and with the help of software frameworks such as PyTorch, TensorFlow, and MXNet. But really, performance depends on the entire software and hardware stack, and there are subroutine libraries and hardware platforms underneath that do a lot of the heavy lifting for training. And so as a result, a lot of the existing profiling tools actually work at these low levels of abstraction. And to use them effectively, users really need to understand everything that's going on underneath the software frameworks. And one of the downsides of this is that it makes these tools really hard to use because it's difficult to connect the performance that these tools show and the code that users write. For example, on the left here is code written in Python for the PyTorch framework, and on the right is the NVIDIA Visual Profiler. And it's really difficult, for example, to connect this high-level line of Python code to the performance traces that are being shown in the NVIDIA Visual Profiler. So in our work, we make the argument that users really should have high-level profiling tools too. And if you look at this diagram, there's space at the top of the stack for a profiling tool that runs at the same level of abstraction as end users. And so that's where Skyline comes in. So Skyline is an interactive in-editor performance profiler meant for deep neural network training. So it currently supports PyTorch, and it runs as a plugin in Atom. And as you can tell from this video, the key idea behind Skyline is to bring domain-specific performance metrics directly into the editor itself, where deep learning users do their development. So I don't have time to go into all of Skyline's features, but perhaps one of the coolest features is that Skyline has manipulatable visualizations. So when you drag them, Skyline will actually suggest, for instance, the batch size that you should potentially use to try and achieve that manipulated performance. So if this sounds really interesting to you, I would really encourage you to check out our full talk and as well as our paper. So Skyline is also open source software, so you can head to our website, which is shown at the bottom of the screen, and you can also install it today through pip and the Atom Package Manager.